Good evening, dear participant, and welcome back in the fourth session on Statistical Inferences Part 2 of the ongoing workshop of biostatistics from basic to advanced techniques. Today, with us in this session will be Dr. Harmanpreet Singh Kapoor, Department of Mathematics and Statistics, Central University of Punjab, Bathinda. So, without any loss of time, we can start this session. I would like to skip the brief introduction because yesterday we have the complete introduction about Harmanpreet Singh Kapoor. So today we are going to start with. So now, dear professor, over to you. You can unmute your mic. Sir, please check if you are able to share the screen.
Thank you, sir. Thank you, Dr. Meher. Let me see whether now I can share my screen. So thank you for that. Okay, so I want to ask the audience whether they have any doubt regarding yesterday's session, if they have any query, whatever we have discussed till yesterday. Because based upon that, I will plan my session today. I will also cover some, you can say, some topic that we are covering in theoretical in our programming also, because I got so much request from the audience. They want to learn that how to do these things in ours. That's why. So,
sir, you have to unmute your mic. Dear participant,
okay.
all the participants are allowed to unmute your mic during the session. Whenever you have any kind of question, you can unmute and put your question directly so that the query can be taken at the same time. And but avoid unnecessary unmute your mic. Carry on, sir.
Okay,
Sir,
thank you.
please carry on.
Thank you, Dr. Mercy. So yesterday we have already discussed that how to do testing of mean for one sample case, in which we already have covered that there are two things we have to keep in mind, whether the sigma is known or unknown. Okay. And the second thing is that whether we have a very large sample size or whether we have a small sample size. For the large sample size, we can also go with the jet test. Okay, but for the small sample size and sigma is unknown, we have to use a p-statistics, right? And we already have discussed that we can also use the criteria of p-value to accept or reject the null hypothesis. The criteria is already discussed with you yesterday. So today we are going to discuss about another that means a test, another hypothesis that is called testing of proportions. And let me give you the brief idea what is that means under that what we do. So now we generally construct a hypothesis about the proportion value. So basically proportion means that among a population, how many observations are affected with particular, how many observations belongs to a particular category. Okay. For example, I can say that among 100 persons, how many persons are affected with the disease? It can be disease A, it can be disease B or not. Okay. So if we have 100 number of persons among a population of size 100, so whatever the left, that is called 1 minus A. So if we are interested to observe the characteristics, that means if our objective is to observe the study, that means how many persons are affected and do we want to study them only, then our p-value will be only A upon 100. Okay, so this is for population. But if we are saying that if we do not have any information about what is the percentage of persons in our population that are affected with particular kind of disease, then we have to estimate it. That means we can give a rough estimate that is called P naught, and we will check that from the sample observation that whether this P naught, whatever the statement that we have given for the population, whether that statement is correct or not. So this is a null hypothesis, and alternate hypothesis can be P is not equal to P naught, or P can be greater than P naught, or P is less than P naught. So these three possibilities can be there. So let me read this case for you. So in the testing of hypothesis for single sample, in the case of proportion, we have categorical values. Okay, so category value can be considered can be considered as success and failure. Okay, success means that possesses a certain characteristics as already discussed with you, that among a population. So if any person in our study we are interested to see that how many persons are affected with the disease, or how many males are there in the population, or how many females are there in the population. So if we consider males as a success or females as success, so the remaining will be our failures. Okay, so now start with an example, and we already have discussed to estimate the population parameter p. We use sample uh, form, that is p bar. So how the sample form p bar is defined as x upon n, where x denotes the number of successes in sample divided by sample size. Hope this idea is clear to all of you. When both n and n1 minus p are at least 5, p bar can be approximated by the normal distribution. So this is a very important result that you have to keep in mind, that for such cases when you product n into p or n into 1 minus p, so if it is coming as 5, okay, in that cases we can use the criteria that mean of the, that means p as a mean of the normal distribution, and this p into 1 minus p upon as a standard deviation of the normal distribution. The reason why we are assuming this, because for large sample size every distribution converges to normal distribution. This is the logic behind that. Okay, and do one example that will be more convenient for you. Okay, so we have example in which a marketing company claims that it receives 8% responses from its mail. Okay, it is obvious that they are mailing to the customers, but they are only getting 8% response back. So to test this claim, a random sample of 500 were surveyed with the 25 responses. A random sample of 500 were surveyed with 25 responses. Test at the alpha is equal to 5% level of sigma. So what we have? So we have this assumption that uh, proportion is 8%, sample size is 500. Okay, so when you product them, so you can see that both are the cases it is coming greater than 5 as the assumption we have above. So we can approximate with the normal distribution, and the mean will be p, and standard deviation will be p into 1 minus p upon l. So what I'm doing, so if you remember the yesterday result, so we have used this form, right? And we also discussed that this form follow normal distribution, or z, this is defined as z symbol for z variable is defined in such a manner, and it follow normal distribution 0, 1. We get the critical value from the normal distribution, right? So here we are saying that for such cases where np is greater than 5, or n into 1 minus p is greater than 5, so we can use p as an estimate of mu, and p into 1 minus p upon n as an estimate of sigma upon n. So we are putting the value in the same proportion, in the same manner, and we got our tabulated calculated value as minus 2.47. So we have to now check, because we assume alpha is 5%, and this is the two-sided test, because we have an alternative hypothesis that is not equal to, so it's a two-sided test. So we consider 2.5% area on the left hand side, 2.5% area on the right hand side, right? And from the table we know that which the value that segregate our normal distribution curve into two parts. One is acceptance region and rejection region, with having 2.5% area on the right hand side and 2.5% on the left hand side is 1.96 and minus 1.96. So we got this value of tested as 6 in the rejection region. In the rejection region, so we can say that whatever the hypothesis we have, null hypothesis we have constructed, that is wrong. So we are going to reject the null hypothesis. Hope this idea is clear to you. Okay, and in the same manner, so when we derive the p-value for the same such cases, so it is also coming as less than 0.05. And how we got the this p-value? So we see that what is the probability that your critical this test statistics value is less than minus 2.47 or greater than 2.47. Okay, and if it After solving it, we got the value as 0.0136, and if it is coming as less than alpha, that is 5%. So based upon that, we can also make a statement that we are going to reject the null hypothesis. And we also have discussed what is type 2 error. Do you remember? Anyone can answer what is type 2 error? So basically, type 2 error means we are failing to reject a false H naught. So what does it mean? It means that we are saying that H naught is true. We are accepting H naught, but actually H1 is true. Right? So type 2 error in which we assumes that whatever the null hypothesis that is given to us, that is correct, but actually it is not correct. H1 is correct. Okay, suppose we fail to reject H naught. Okay, this is one example in which we assume that mu is greater than equal to 52. Okay, but in fact, the true mean was mu is equal to 50. So we assume null hypothesis that mu is greater than equal to 52, but actually it is incorrect. So actual value for mu is equal to 50. So in such cases, one can also plot the normal distribution. Okay, and here the mean is 50 and here the mean is 52. So here you can see that. So we reject our H naught mu is greater than 52 till this stage, because this is a critical value. This is a critical point that divides the normal distribution curve in two reasons. This one is called rejection region, another one is called acceptance region. So whenever we got the value in the rejection region, we are going to reject. Okay. So in the same manner, we can do the same thing for other cases also. So basically, today I want to discuss with you that is testing of hypothesis for two samples. This is the main thing we want to cover today, and we will have examples of the same in our program also. So I want to cover that. So now, what we have covered in the previous case. So let me tell you, and what is the different thing we are going to cover now. So in the previous case, we do the testing for the mean. Okay, and we do the testing for the mean for one sample. So what is the meaning of one sample? One sample means we consider only one group at a time, and we are trying to make a statement regarding that mean value of that. Okay, let me give one example. Yesterday, I think we have discussed an example of expenditure in households. Okay, expenditure of household living in a society. Okay, so let us suppose mu represents the average expenditure of households those are living in a society, and mu naught is a value given by me. So value, it can be the value that 20,000 is the expenditure of households those are living in society A, right? So now, if I want to make a statement that there are two societies A and B, so whether the expenditure of mean average expenditure of society A is equal to mean expenditure of society B or not. So now we have two groups, and we want to make comparison of these two groups. So this is a case of two samples. Okay, and alternative hypothesis, we already have discussed that there are three possibilities. Either this is not equal to mu is A is not equal to mu B. Second one is mu A is greater than mu B. Third one is mu A is less than mu. So when we have an alternative hypothesis not equal to, then it is called two-tailed test. Two-tailed test. Why so? Because we will construct our rejection reason on the left hand side as well as on the right hand side. Okay, I think this is clear. So when we have mu A is greater than mu B, so we have one-sided test, and that was upper tail test, because we want to see that mu A is greater than mu B or not. So we observe the difference on the upper side. So when we have mu A is less than mu B, so we will construct our rejection region on the lower side. Okay, and this is called left tail test. Okay, upper sided or lower sided test. So now, we have three further categories of for the testing of two population or two samples. Hello. Okay. Okay. So let me, Shanu, can you tell me which thing you want to discuss? Or is there anything that I left you want to discuss? You can.
Yes, please. Good evening, everyone. Sorry, please.
So is it fine now? Should I continue or you have some doubts?
I have some little questions from the two
Okay.
sample testing of hypothesis.
Yeah, you can ask.
A little explanation from the beginning, please. Sorry, sir. Sorry.
Okay. So basically, in the one sample case, what we have covered, we have only one group, right? That means
Yes, sir.
we have discussed the example yesterday that we want to observe the mean expenditure of the people, those are living in one society, right? So what we have constructed a hypothesis that mu represents the mean expenditure of the families living in a society, and I give one value mu naught from my side. Mu naught can be any value, it can be 20,000, 30,000, any numeric value. Okay. So we already test this hypothesis, and alternative hypothesis can be mu is not equal to mu naught, and mu is greater than mu naught, and mu is less than mu naught. There are three possibilities, and based upon that, we will construct our means test statistics, whether it is a two-tail test, it is a one-tail test on the upper side, it is a one-tail test on the lower side. So in the same manner, if I want to, if I have two societies now in place of one society, and I want to test whether the mean expenditure of these two societies are equivalent or different. So what type of hypothesis I will construct, that is mu A is equal to mu B, where mu A represents the mean expenditure of people living in society A, mu B represents the mean expenditure of people living in society B, and alternative hypothesis will be mu A is not equal to mu B, mu A is greater than mu B, and mu is less than mu B. When we consider this such case, mu A is not equal to mu B, then it is called a two-tailed test. Okay, when we consider mu A is greater than mu B, it is a called one-sided upper tail test. When we consider mu A is less than mu B, it is called one-sided lower tail test. So it is fine now?
Yes, sir. It's fine, sir.
Okay, thank you.
Thank you, sir. Thank you, doctor.
Okay, so now what we have so already have discussed that in the two population we have further three categories. So I have to explain this. So as we know that we are doing testing of mean or testing of proportions, there are only things we are going to cover in this PPT. So what is our main objective? Either do testing of mean or testing of proportions, right? So here you can see that if these two groups are independent, that means because we already have this assumption that I'm talking about two different societies, so these groups can be considered as independent. Okay. The second possibility can be, so let us suppose if I want to say that mu1 represent is the family members of society A. Okay, I have observed. I want to test that their expenditure in the year of 2023, and this mu1 shows the expenditure of families living in society A in 2023, and mu2 represent the mean expenditure of families living in society A in the year 2020. So it means I am considering same population, but at two different time periods. So this is called paired sample. The idea is clear to all of you. So when I consider mu1 and mu2 as two different groups, then they are called independent samples. When I consider mu1 and mu2, the same group at two different time periods, then they are called paired sample. Okay. And the third possibility is population proportion, in which I consider two different groups and observe their proportion values. And I'm going to make a statement that the proportion values are equivalent to each other. So you can say that example is group 1 is independent of group 2, same group before and after treatment. Third is proportion of first group and second group. And you can also think about the example of paired sample. Let us suppose there are some few patients, that is those are diagnosed with the disease A. Okay, and they got diagnosed in the year of 2023. Now after getting treatment, so now listen to me again. After getting treatment, what is the status of those patients disease level in the year 2024? If you want to see such, if you want to test such cases when the patient are same, but we are observing them at different time interval, then they are called paired samples. Is it clear? Okay. So now, because in the first case, we want to make a comparison of mean of two groups among the means of two groups. So, and the samples are independent. So we consider them as difference between two means. Okay, so we can also write down our null hypothesis as mu1 is equal to mu2. This is the one way. Second way was mu naught is equal to mu1 minus mu2 is equal to 0. Both has the same meaning. Okay, and we already have discussed yesterday that while testing for the mean, we also have to make some assumption regarding, we also have to see whether the sigma is known or unknown. Okay, if it is known, then the test statistics will be different. If it is unknown, the test statistics will be different, right? So we are assuming that here in this example, that there are three possibilities. That sigma 1 and sigma 2 are known to us. The second possibility can be sigma 1 and sigma 2 are unknown to us, but n1 and n2 is greater than equal to 30. So yesterday we already have discussed that for sample size more than 30, sometimes we approximate that in place of T we can use jet test, but we again have to cross check whether the data set follow normal distribution or not. Okay. The third criteria says that sigma 1 and sigma 2 are unknown and the sample size is less than 30. Okay, hope this idea is clear to you. So what is the form of the test statistics? Let me explain to you. Let me come directly to the test statistics formula. So the formula for the test statistics is this one. Okay. I have to write down here because here confidence interval is given first, then we will discuss about the test statistics. The formula for the test statistics was x1 minus x2, okay, minus mu1 minus mu2 divided by sigma 1 square upon n1 plus sigma 2 square upon n2. So this formula is valid when sigma is known to you. Listen to me again. When sigma values are given to me, then I will use this formula and this expression follow normal distribution. Okay. So what's the meaning that this formula follow normal distribution? In such case, we will see the critical value from the normal distribution. Okay. When sigma is unknown, now see the difference. When sigma is unknown, so we will use this formula mu1 minus mu2 as 1 upon n1 plus 1 upon n. And what is S? S is defined as a pool estimate standard deviation. And it follow T distribution with degree of freedom n1 plus n2 minus 2. So I think you do not have to remember these formulas but I have to explain this to you that when sigma is unknown, then we will use this formula and it follow T distribution with degree of freedom n1 plus n2 minus 2. Okay. And when you will do these things in R coding, so we just have to observe the p-value. But you must have to know that under which case we will go for t-test, under which case we will go for z-test. For that, we have to keep this thing in mind that sigma is given to us or sigma is not given to us. If sigma is given to us, then we have to go for z-test. Okay, if sigma is not given to us, sigma 1 and sigma 2, they are not given to us, then we go for t-test. Okay. And the third case, in which case, when sample size is very large, so we are estimating sigma 1 and sigma 2 from the sample observation, but in place of t, we can also approximate by z because in such cases, t is converging to z distribution. So you can also see that whatever the value of t we will got from the table, that seems to be similar to the value of z from the normal table because they have a relationship for the large sample size, t converges to z distribution. This is the logic behind it. Okay. I already have explained these things, so I am not spending time because I want more time to be spent on the R program. Okay. So now coming to the paired sample. So what is paired sample? As already explained to you that we have the same population and we want to see the value of the same population at different time periods. And we want to say that whether there's any significant improvement or significant difference comes in the mean response of the same elements at different time. Okay. So it means we are saying that if mu1 represents that you can say measure of BP, or blood pressure or sugar level of the patient in the month of on 1st August, for example. Okay. So mu2 represents the BP or sugar level of the patient on 24th of August. Okay, so what we are doing, we have the same patients, but we are observing their mean BP value at different time periods, and we want to say that there is significant difference in the mean value of the BP or sugar level or diabetes level, and whether that is there is any significant difference or not, or they are equal or not. So this is the main objective. I think this idea is clear to you. So to determine this, to make a conclusion whether the statement is true or false, so we have a mathematical form of the test statistics that is given as d bar upon s upon under 10. That follow t distribution with n minus 1 degree. Okay, so what is d bar? D bar is defined as summation of di upon n. What is di? Di is the difference of each observation. It means when we are talking about 100 patients, so what we are doing, we consider first patient and subtract the value of the same patient at different two time periods. For example, this xi1 represent x11 represents the value of the patient 1 on 1st August. Okay, so x21 represents the value of the same patient on 24th of August. So what we are doing, we are taking the difference. So now it is possible that DI values can be negative. So listen to me, DI value can be negative. So it doesn't make any difference, because if it is negative, then we have to test the test statistics on the lower interval. If it is not equal to, that means we have a alternative hypothesis defined as mu d is not equal to 0. Null hypothesis mu d is equal to 0. What is mu d? Mu d represents that there is no significant improvement in the values of the patient. So that is a null hypothesis. Alternative hypothesis will be mu d is not equal to 0, and it can be mu d is greater than 0 and mu d is less than 0. Okay. So if we got most of the values as negative and we have two-tailed test, so we can also see the difference. We will also see whether our value of the test statistics lie in the rejection is on the left-hand side or on the right-hand side. So based upon that, we can come to a conclusion. Okay. So now similarly, when we observe the second patient value, okay, so what we do, we consider x12, and here we also consider x22 and then take the difference. Similarly, we first derive the difference of the patients at two different time periods, and we then add them and divide by the number of sample size. Similarly, we derive the standard deviation, this formula. Okay, so now what we do, we put them in this expression. Let me write down the expression. I think I have already written here. The expression was, okay, d bar upon s upon under 10. Okay, that follow t distribution with n minus 1 and alpha by 2. N minus 1 degree of freedom. With alpha by 2 is the, if we consider the critical value, we will take this alpha by 2. And if the value of this t is coming to be greater than this Tn minus 1 alpha by 2, then we reject the null hypothesis, or otherwise we do not reject the null hypothesis. And you can also make a statement from the p value. If the p value of this t distribution is coming to be less than 0.05, then we reject the null hypothesis, otherwise we do not reject the null hypothesis. Hope this idea is clear to all of you. Okay, so we have the summarization here. Lower tail test, in which we consider one-sided alternative, either less than upper tail test, in which we consider upper sided alternative. Two tail test, in which we consider not equal to sign. Okay, I think we should move to first R. Then we will cover the rest of topics if there is anything. I already have explained this thing to you. So if someone has any issue, one can ask. Okay. Okay. So let's do one example first, then we will move to R. Okay, the example says, so you are a financial analyst for a brokerage firm. Is there a difference in the dividend yield between stocks listed on the NYSE, New York Stock Exchange, or Nasdaq? So you collect the following data. So what we have a numbers that is 21 and 25. So this shows the sample values. Sample mean is given as 3.27 and 2.53, and sample standardization is given as 1.30 and 1.116. So what is our basically what we are trying to test? So is there a significant difference in the dividend yield between stock listed on the NYSE and Nasdaq? So what they are trying to say, so I think all of you are aware about the term dividend. If you're not aware about term dividend, let me tell you. So when you invest your money on the stocks in which you opt for the option that if a company earn any profit, then they distribute the profit among the shareholders. So that profit distribution is called dividend. Okay, and dividend yield means, so when you divide dividend by the price of the stock, that is called dividend yield. Hope this idea is clear to you. So now what we are trying to say that if someone is investing the money on the New York Stock Exchange and second one is investing money on Nasdaq, so they want to make a comparison that if whether the investment of money in the NYSE has a different dividend yield as compared to Nasdaq or not. The statement is clear to all of you? Okay. So now you can see that, so we are saying that if mu represents the average dividend yield from NYSE, and second one is mu represents the average dividend yield from Nasdaq. Okay. So we want to make a comparison whether these mean yield, dividend yield are equivalent or different. Okay, for that we have such information given that we consider a sample of size 21 from NYSE, and second one is Nasdaq that consists of 25 sample observation. And we have already assuming this assumption that the variance of these two groups, they are equivalent. Okay, and we are doing the testing with 5% level of safety. This statement is clear to all of you. Okay, so now we already have discussed the form of the test statistics that it was x1 bar minus x2 bar minus mu1 minus mu2. So can you tell me why this is 0? Because in the null hypothesis, we have written that mu1 is equal to mu2. So whenever we solve the test statistics, so we consider the values from the null hypothesis. So in the null hypothesis, these two values are equal. That's why it is written as 0. So the formula for SP is given below, and already have mentioned the formula for the SP, that is N1 minus S1 square, N2 minus 1 S2 square, N1 plus N2 minus 2. And what is N1? N1 represents the sample size of the first group, N2 represents the sample size of second group, and S1 square represents the standard deviation of the sample variance of the first group. S2 square represents the sample variance of the second group. Okay, so we are putting the values in this formula, and we got the formula value for the SP as SP stands for standard deviation of the pooled estimate. So that is 1.2256. We are putting this here value here, and after solving, we got 2.040. So we know that sigma are equal, but they are unknown. So it means this test statistics form follow T distribution with the degree of freedom N1 plus N2 minus 2. Okay, so now what we do is we see that T table, and we know that what is the sample size for N1, that is 21. What is sample size for N2, that is 25. So we are subtracting the value 2. So we know that if we add these two terms, we got 46 minus 2, that is 44. So we see the T value table at 44 degree of freedom at level of significance as 2.5%. Because it is a two-tail test. Hope this is clear. Okay, so when we check, so now you can see that, so when we see the T distribution table, so we got the critical value as 2.014. Okay, but we got the value as 2.040. So 2.40 is little higher than. Yes, Shayu, you can ask your question. Is there anything that someone wants to discuss from the audience? Hello. Okay. So now you can see that 2.040 value is little higher than 2.0154. So our value of the test statistic lie in the rejection region. So now we are going to reject the null hypothesis, and we are going to conclude that there's a significant difference. We can't say whether Nasdaq is performing well, or this NYSE is performing well. We can only say that there's a significant difference in the dividend yield. Okay, if you want to check further, you can make another test hypothesis in which we consider that the mean yield of NYSE is more than this Nasdaq, and based upon that, if it is got rejected again, then we can say that NYSE performance is better than the Nasdaq. Okay. Okay. So now we are coming to the testing of pair sample. As already discussed with you, that the test statistics is defined as D minus mu D, D bar minus mu D. And because the null hypothesis, we assume mu D is equal to 0. So after putting 0 here, we got D bar upon SD upon under 10. And we solve this, then we have to compare the value with the T distribution. Okay. And based upon that, we come to our conclusion. So this is one example. So assume you send your sales people to a customer service training workshop. So we want to know that whether the training is effective or not. So now, because we have sent the persons, okay, to take some training. So let us suppose we can also think about the same example in our case also. So there are few persons, they have enrolled such type of course first time. That means they have enrolled for the biostatistics course first time, and we want to know whether this course is beneficial for them or not. So how we will get that? We prepare some questions. We ask those questions from the audience before joining this course, and we ask the same question or similar kind of question to the audience after completion of the course. Okay, if there is a significant improvement in the knowledge of the audience, then we can say that this course is beneficial for them. Otherwise, we can say that this course has no such significant benefit for the audience. So in the same manner, if there is a customer, that means a salesperson are assigned some, that means they have to attend some training workshop. So we want to know whether training is effective for the salesman or not. So what we can do is because we want to know that after joining the training workshop, whether there's any significant decrement in the number of complaints after joining the training or not. So this is the list of the number of complaints before joining the workshop, and this is a list of the number of complaints for the 5 salesperson after the completion of the training program. Okay, so now we know that to find the value of D, we have to take the difference of this same person value at 2 different time periods. So when we take the difference, some of the values are coming negative, some of the values are coming positive. So when you add them, so whatever the value will come, we have to consider that, and we derive the mean bar. Okay, so after that, we have derived the standard deviation. So now we have to take proportion of this D bar upon SD and square root of n. So when you put the values in this formula, so we got the final answer as minus 1.66. And we also have discussed that whether training has no significant improvement in the performance, or training has significant improvement in the performance. So we are observing the performance both side, either it is negative side or either it is the positive side. So you can see that because after attending this training program, there is a significant decrement. Okay, there is a significant decrement in the complaints. So if this value lie in the rejection region, then we can say that training has a significant impact on the customer behavior. That means that helps the customer behavior, that leads to less complaints that we got from the customers regarding the salesman persons. Okay, that means after getting the training, your salesmen are now very efficient, that they take care of the customer complaints more efficiently, or they talk to the customer more efficiently. So there will be no complaints comes from the customer sides regarding the salesman. Okay, So now, because we can see that this value 1.66 lie in the acceptance region. So when it lies in the acceptance region, that means we are not going to reject this null hypothesis. So what is this null hypothesis? Says that attending trainee has no significant impact uh, in the improvement of the sales force behavior, or you can say that there is no significant change in the number of complaints. Both have the same meaning. Okay, hope this idea is clear. So what we have covered today, we have covered till now two sample cases in which we have covered that H naught is mu1 is equal to mu2. Okay. In that case, we also have such information as sigma 1 and sigma 2 are known or unknown. If they are known, then we have to go with the Z test. If they are unknown, then we go for the T test. And if we have paired samples, so this thing we have done for the independent samples, but if they are paired samples, then it again follow T distribution, but the way to derive the test statistics is different. Okay. Now the third case is when we want to make comparison of two sample proportions. And we have this information given that N1 P1 is greater than equal to 5 and 2 P2 is greater than 5 and other possibilities. So in such cases, what we have to do, we have to first derive the grand, or can say overall proportion. And the formula for the overall proportion is defined as x1 plus x2 over n1 plus n. What is x1? X1 is a sample observations. Okay, sample observation that has that belongs to the characteristics of success. X2 represents sample observation that belongs to characteristics of success in the second population. So N1 represents the sample size of the first group, N2 represents the sample size of the second group. So we compare, we put this expression in this formula, P1 minus P2 and P bar 1 minus P bar, and it follow normal distribution. Okay. So whatever the value we got here, we compare this value from the standard normal distribution table. And if the value of this Z lie in this rejection region, because if it is a two-tailed test, then we see on the both sides. If this lies on the rejection region, then we can say that whatever the null hypothesis we have prepared, that is incorrect. Okay, and if it is a lie in the acceptance region, so we can say that whatever the hypothesis we have framed regarding the equality of the proportion of two samples, that is fine. Hope this thing is clear. Okay. Yeah. Okay, this is one example. So you can see that the example says, is there a significant difference between the proportion of men and the proportion of women who will vote yes on proportion A? Now listen to me again. Is there a significant difference between the proportion of men and the proportion of women who will vote yes on proposition A? Okay, so now you can see that our objective is who will vote yes. So we have defined two groups. One is men and second is women. Okay, clear? So we have taken a random sample both from male and female, and we will see that among a male of sample size 72, how many persons who will vote yes. So there are 36% who vote yes, and among a sample of size 50, among female sample of size 50, we got that the 31 would provide or would vote yes. Okay, so we will test whether this proportion is equivalent or not at the 5% level of significance. Okay, so now we construct our null hypothesis as P1 minus P2 is equal to 0 and alternative y as P1 minus P2 is not equal to 0. So we derive the proportion from the sample by dividing x1 upon n1 and from P2 x2 upon n2. Okay, we got 0.50 for the sample for the men and 0.62 for women who would vote yes, right? So now we have derived P bar, that is a pooled estimation, and that is x1 plus x2 upon n1 plus n. So we put the value in this expression, we got 0.549. Now we put all these values in the mathematical form, this one. Okay, and after solving this, we got the final answer as minus 1.31. Okay, now we have to see that because we already have discussed that this Z follow normal distribution, and we know that the critical value for the normal distribution at 5% level of significance on both sides was minus 1.96 and 1.96. So this value lie in this region. Okay. So now this is called as acceptance region. So now what we conclude? We conclude that we are not going to reject the null hypothesis. And what is a null hypothesis? That proportion of male and female, okay, will be equal. Who would vote yes to proportion to proposition A, right? So whatever the null hypothesis we have made, that is correct in this case. Okay, this is clear. If someone has any doubt, then one can ask me. Now I'm moving to R program. Till this stage. Should I continue with R code then? Are you with me? Okay. So now, yesterday I already have discussed with you that this is R Studio that I'm using here. And it is more convenient because at the backend, it use R software, but it is more user friendly as compared to directly use R. So we are using R Studio, and this is the interface of R Studio in which we have this is Notepad, or you can say R script. This is called console. So whenever we want to execute any code, we run the code from here and it will be executed here. That is called console. Okay, and here this is called your environment, in which whatever the values you stored in the name of variable, that will be shown here. And here we can see that so let us suppose if I am which directory I am using, working directory, that will be shown here. So if we will construct any plots, that will be shown here, and packages, how many packages I have installed in my system. And if we want to update or install new packages, you can install it from here, right? Help means if you want to know about any function, like yesterday we have searched for mean, but it was not working at that time. Now it is working. So you can see that when you want to do any, you want to implement any function, but we do not know the syntax. So just have to write down the function name from theoretical point of view even. So it will provide you that how you can derive that function in R. So let us suppose if I want to derive the mean of the vector or sample observation, then I have to first store the values, or I can directly put the values in a vector, and then it will use the function mean that will give the mean of the observation. So let me tell you what I'm trying to say. So let us suppose if I want to derive the mean or the sample observation. So first I have to create a vector. So this X means I am storing the value, whatever I am going to create on the right hand side in the X variable name. Okay. So now, so I think the screen is visible to all of you. Size is fine.
Seems to be fine, sir. Looking fine.
Okay, I am trying to maximize the font size, but it is not. Let me see. Okay, so if it is clear to all of you, then it is good. Okay, so now what I'm trying to say. So now I want to derive the mean of vector X. So first I have to tell you that how to create a vector in R4. So there is a function that is called C bracket open and bracket closed, and it is also called concatenate. So what is the meaning of concatenate? That means we want to club the variable values or observation in one group, in one vector. So let us suppose I have inputted 3 values or 5 values here. So now I have stored these values vector in X. When executed or type here X, you can see that now this X variable consists of 5 observations, and these 5 observations are 23, 54, 67, 54, and 57 that I already have written. Clear? So now if I want to derive the mean of this vector x, either I can directly type mean of x, but I want to store the values of mean of x to another variable y. So I first have to write down y, then use a syntax equal to, and there is another way that is called y is less than hyphen mean. Both will work. Both has the same meaning. Okay. So when I execute the function, that means I execute the syntax. So you can see that it will be executed at the bottom, and the output is coming as 51 for the first case. That means when I assume y is equal to mean. In the second possibility, y is less than hyphen mean. When I execute it, I type again y. You can see that the answer is coming as 51 again. So it means either you can use equality symbol for assigning the value, whatever the value we have on right hand side to left hand side, or either you can use a symbol less than hyphen that will do the same task. Okay, great. Okay, so now I want to show there are a lot of things that one can do in R, but because of shortage of time, I am going to give you some important things like how one can create data frame, how one can create a vector, how one can call the data. That means call the data that is stored in Excel format. How one can call the data that is stored in CSV format. If someone has any delimited file, how can call that file? Okay, so I have already written the syntax for your understanding. So, but I'm going to explain it. Don't worry. So the next example that I want to discuss with you, that I want to create a data frame. So can anyone tell me what do you mean by data frame? Do you have knowledge of the term data frame or not? Okay, someone has asked. Okay, so data frame means, so let us suppose we want to conduct a survey. Okay, and a survey consists of different questions. Agree with me? So let us suppose you want to conduct a survey, and survey is regarding, you can say you want to know the monthly expenditure. Because why I'm consider one example, because you can consider the same example in different scenario. So I want to know the monthly expenditure of households, but how I can get this information? So for that, I have to ask them, and to get the information, I have prepared one questionnaire. Okay, in that questionnaire, what things I will incorporate? The first thing is I can incorporate the name of the person. I can incorporate that what is the sex of the person, what is the gender of the person, what is the religion of the person, what is the age of the person, what is the occupation of the person, or what is the education level of the person. Okay, I can also ask how many you can say uh, how many utensils the person has in their homes. I can also ask about how many vehicles you have, how many two-wheelers, how many four-wheelers, how many fan, how many tube lights, and what is the income of, what it means. I can also ask the income of the person. So I have various questions. So now you can you tell me that gender, religion, and you can say caste, this this variable belongs to which category, whether it is a quantitative variable or whether these are qualitative variables? My question is clear to all of you? So in a questionnaire, we have various varieties of questions. Okay, some of the variables are categorical, some of the variables are non-categorical. So I have asked you whether sex gender or sex or religion or education qualification, so they are qualitative. Why so? So because when we talk about the data, so there are two major categories. One is called quantitative and second one is called qualitative. Okay, in the qualitative, further we have further categorization. One is called nominal, second one is called ordinal, and third one is called binary. In the binary means, so when we observe the characteristics, when we observe any variable, when we observe the characteristics of the person only in terms of categories. Okay, for example, I will ask you whether you like ice cream. So you will say yes or no. So you have only two options, either yes or no. Okay, so for the analysis purpose, I can't quantify how much you like or how much you dislike. I can only say that the person like or dislike. For the analysis purpose, we can assign value 1 to yes or 0 to no. Okay, in the same manner, so when we ask about the person, what is the sex of the person, what is gender of the person? So person can be male, the person can be female, and the person belongs to third category, third gender. So we have option 1, 2, 3. But now here 1, 2, 3 means we are just assigning numbers to them, right? So here it doesn't mean that 1 is better than 2, 2 is better than 3. So such cases will comes under qualitative, in which we just assign number to them because we can do the analysis. Okay, here 1, 2, 3 has no quantitative value. Okay, we can't say that 2 is more than 1, 3 is more than 1. Okay, but we just assigning numbers to them. Okay, so this is the case that is called nominal, when we have more than two categories and these categories have equal weightage. Now come to education qualification. Okay, so now come to education qualification. The person can be graduate, the person can be postgraduate, the person can be PhD holder, the person can be illiterate also. So now when we assign numbers to them 1, 2, 3, 4, so we can order them based upon the level of qualification. Okay, so we can assign maximum value to the person who is holding PhD. We can assign value 4 to that. We can assign value 3 to a postgraduate person. We can assign value 2 to a graduate person. We can assign 1 to a illiterate person also. Okay, so here the difference is that it is called ordinal, because we can assign values to the categories, but these categories can be ordered. Okay, that's why it is called ordinal. So data frame consists of both qualitative and quantitative observations. Okay, so in the data frame, we have some variables that consist of qualitative information. There are few variables that consist of quantitative information. So that's why it is called data frame. Okay, so now example that I am considering here. So in which I want to prepare the employees data. Listen to me again. I want to create an employees data and I want to assign IDs to each of my employees. Okay, and what I'm trying to incorporate, I want to incorporate the employees ID. I want to incorporate their names. I want to incorporate their salary. I want to incorporate when they have started their job. Okay, and I want to see that whether there is any string quantity is given in this data set or not. So what is string? Can you tell me if someone has heard about the term string? Okay, string means, so let us suppose when anything in coding part, when anything is written in inverted comma, or you can say that is not defined as a numeric value. It can be alphabets, it can be numeric value within the inverted comma. So when we have such cases that all these things comes under string, that is non-numeric, you can think about for a general purpose. So now what I am doing now, so I want to create a data frame for the 5 employees, and whatever the information that I'm going to incorporate is I want to assign the employee ID. I want to incorporate their names. I want to incorporate their salary. I want to incorporate when they have started. So now you can see that data.frame is a syntax. So now when I'm typing data.frame, so this pop-up will come, and what this pop-up is showing you that whatever the arguments we can incorporate in this data frame. So we can incorporate row names, we can incorporate whether how many rows are there, whether they are non-empty rows or not. We can also check their names. So there are various possibilities. If you want to learn more about that, you can go to this help and you can type data.frame, and that will give you more information about the function data.frame. So when I write this data.frame, so we have to put each observation or vector in this parenthesis bracket only, right? So what I have done here is I have taken this variable name employee ID in which I have stored values 1 to 5. So 1 colon 5 means starting from 1 till 5. Okay, when I execute this command independently, you can see that 1, 2, 3, 4, 5 will come. So I want to store the value 1, 2, 3, 5. And what is the purpose of that? Because I want to assign 1 to my first employee, Rick, 2 to Dan, 3 to Michelle, 4 to Ryan, and 5th to Gary. Okay. So now in the same manner, if I want to store the names of the employees. So as we already have discussed that when we want to store anything to variable, we have to put value in this function C bracket open parenthesis open or bracket close. It is also called concatenate function. But if you want to store the name, that means alphabet value, we can't write directly. We have to put them in the inverted comma. So that's why we have kept in the inverted comma and differentiate by the comma. So it means we are now assigning 5 names to the variable name employee name. In the same manner, so if I want to store their salaries also. So here you can see that each first observation belongs to Rick, each second observation belongs to Dan, each third observation belongs to Michelle, and each fourth observation belongs to Ryan, and each fifth observation belongs to Gary. Okay, so if I'm writing here 62, 623.3, that represents the salary of Rick, and so on. If there is any value that is called as dot date, that is 1st Jan 2012. That means this person Rick has joined the company on 1st January 2012, right? So as dot date, why we have written? Because we want to store the dates, and dates are not numeric, not alphabet. So we have to assign this special symbol, a special function, which we are trying to say that. So whatever the information we are storing in this function as dotted, that is actually the calendar values. And when we try to execute this command, so it stored these values as a calendar values. Okay, clear? Okay, so there is a one thing, string as factors is equal to false. So what is the purpose? So what they are trying to say, string means these values. So they are not factors. Factors here means that there are sometimes some values that are repeated multiple number of times. So here, because they are unique values, so that's why we are saying that string as factor is equal to false. So what is going on here when I execute this command? I have created a function data.frame on the right hand side. Now what I am doing, I am storing this data frame that I have constructed on the right hand side in the variable name employee.data. And one thing you have to keep in mind that this variable name is my subjective thing. I can use any name on the left hand side, but I can't change this function data.frame. So if you want to create a data frame, then you have to use this syntax data.frame. If you want to use this function as.date, you have to use the same syntax. There is no, you can say R is a case sensitive language. So you can't say that as.small dat can also work. So you have to write in the same manner. A in a small letter, S in a small letter, then dot, then D in a capital letter. So only this will work. So when I execute this command by using this key shortcuts as Control plus Enter, so you can see that it is executed without any error. Now I want to see what is stored in this variable name as dot employee dot data. So when I execute this command, you can see that so 5 rows has been constructed. In the first column, we have the values for the employee ID. In the second column, we have values for the employee name. In the third column, we have values for their salaries. In the fourth column, we have their starting date. Okay, hope this idea is clear to you. And if you want to print it, that means either you can directly write down employee.date or either you can write print that will give the same output. Hope this thing is clear. Why I have discussed data frame, because when you want to it means handle very large data set that is given to you in terms of vectors, in terms of Excel file. Either you can directly import that data, okay, using this function that I'm going to discuss today and store them into data.frame. So let me tell you what I'm trying to say. Okay, so let us suppose you have some file that is that you have in Excel form, okay, or CSV format. So you want to call that file in the R program. So as already discussed with you, for a specific function, we first have to call the libraries. Okay, so let us suppose I want to execute that. I want to call my one CSV file that is stored in this location. So this is the path in which my file is stored, right? So what I am going to do now, I want to call that file and store that file in this variable name dd. So for that, I have to use this syntax read.csv, then inverted comma, the path on which my file is stored. Then I have to just execute it, and you can see that it will be give me the information. Okay, so this is a file that I have with me, and I want to just show you that how one can call Excel file or CSV format file that is stored at a particular location in the R code. And if you want to see that what type of information you have in such type of file. So let us suppose I am calling my Excel file. I want to see the first 15 observations that is stored in that file. So this is syntax that is called head. Head means top 15 values of the file. That means data frame with a variable name dd. I want to see that. Okay. In the same manner, if you have some information given to you in terms of text file, so this syntax will be used read.delim file.choose. So what is the purpose of file.choose? So let us suppose if you do not know the path, or you are not very much sure that if you will copy the path, that will be correct. So the second option says that you can use this function file.choose. Then when you execute this command, a pop-up will come. Okay, what is the purpose of this pop-up? Pop-up means now you can go to the location of the file where the file is stored, and you can go to that location and you can select the file. Then you can click on open. That file will be opened directly. Okay, so there are two ways. Either you can copy the path of the file, or either you can use this function file.choose, in which you can go to the select your desired path where your file is stored, and you can select it, and then you can copy whatever the content you have in that file in the variable name my_data. Okay, in the same manner, if you want to call the file CSV format file from the location where it is stored, not direct, you do not know the location, but you want to go there by clicking method, then you can do that. So now comes to today's topic that we have discussed. So okay, let me tell you the brief about what we are doing in this example. So in this example, I have considered a case that I have observed the height of plants or trees, you can say. Okay, so what I am trying to say, so this value 110, 112, 114, 116, these value represent the height of the trees. So how many values I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Either I can calculate it here, or either I can use the function length. Let me execute both the commands. So manually I count that manually I already count as 10. So when I use the function length, it will give the value the same thing. That means how many observations we have stored in this vector height. Okay, so what is my objective? So I want to say that, so I have collected information from the 10 trees. I observe their height, and I want to make a statement that on average, the height of the tree is 120. I think this objective is clear to you. So we are dealing with one sample test in which I consider one group, that is height of the trees. Okay, and I am making a statement that on average the height of the tree was or is 120. I want to test that thing. Okay, so now in R, it is very easy or simple to do the testing, because we know that I have only information about the mean of the height of the trees. I have no information about their variance. So it is obvious that we have to implement t-test. as already discussed in the yesterday session, when we want to do the testing for the mean and sigma is unknown, in that case, we will implement t-test, right? So what I am doing here is I am using a syntax t.test. I'm using a syntax t.test, and I'm using the values that I got in the variable height. I'm putting it here, and I am giving that observed values that from my side, that mu is equal to 120. That is the value of mu naught. From my side, I'm trying to say that on average, the height of the tree was or is 120. I want to test this statement. So when I execute this function, so see what is going on here. So it shows that we are using one sample t-test, that is fine. And it shows the value of t, that is mathematical form of the test statistics with degree of freedom 9. We know that for the one sample, the degree of freedom for the t-test is n1, n minus 1. So we have n as 10, so that degree of freedom will be now 9. So what we got? We got p value as 0.6105. So what does it mean? It means that p value is more than alpha. What is alpha here? 5%. All of you agree? Are you with me? Let me tell. So tell me if you are with me.
Yes, sir. Yes, sir. It's okay.
Okay, fine. So what I am trying to say, so if p value is coming greater than 5%, so whether we are going to accept or reject the null hypothesis. Can anybody answer? If p value is greater than alpha, so we do not reject the null hypothesis. So it means that whatever the null hypothesis we have made, so which null hypothesis we have made, that mu is that mean height of the tree is equal to 120. That is correct based upon the observed values. So we can say that this statement is correct. So there is no any doubt. So on average, we can say that the average height of the tree is 120. All of you agree? Okay. So now similarly, we can also see that it also provides us the confidence interval. So can we make the same statement from the confidence interval? Yes or no? Can we make the same conclusion? Can we get the same conclusion from the values that we got from the confidence interval or not? The answer is yes. Why so? So can you see the lower limit of the confidence interval? It is coming as 113.6547. And what is the upper value of the confidence interval? That is 123.9453. So 120 lie in this confidence interval or not?
Yes,
Hello?
sir. Yes.
Okay. So 120, if it lie in this confidence interval, so it means that our confidence interval consists of the this mu naught value. So it means that whatever the statement that we have made in the null hypothesis, that is correct. So if the confidence interval doesn't consist of the value that we have defined in the one sample null hypothesis, so we reject the null hypothesis. This is another way to test the hypothesis from the confidence interval, right? So now I'm going to repeat this example for the two, you can say, for the two sample test. So how I can do that? So you have to be with me to understand this. So now I have already given next example. Okay. So first let me tell you another example. So this is one example in which I am considering the level of spending in one city, that is called sea level. And they say another variable that is stored here as New York spending. So what I am trying to say here is I consider two cities. One is sea level and second one is New York. And I want to observe their spending. And I want to test that the spending of these two cities or places, whether they are equal or unequal. Okay. So because I want to generate a very large data, so what I have done here is I take a help of the random number generation. So but basically what is random number generation? So here I use a function rnorm. So let me tell you, first I have to explain what is the meaning of rnorm. Rnorm means I want to generate random numbers or observations from the normal distribution that has mean as 250 and standard deviation as 75. So listen to me again. So what I am doing, I am generating or I am extracting 50 values from the normal distribution that has mean value as 250 and standard deviation as 75. So when I execute this command, so you can see that it got executed easily. And what is stored in this C level values? Let me show that. So I got 50 values from the normal distribution that has mean as 250 and standard deviation as 75. Hope this idea is clear to you. Similarly, I want to have 50 observations from the New York City, in which I assume that the mean expenditure is 300 and standard deviation is 80. Okay, in the same manner, when I execute this command, so you can see NY spending. We got these values. So now what we want to do? We want to test that whether the mean expenditure of sea level and New York City is equivalent or different. Okay, so now forget about from where you will get this data. Listen to me again. You just have to think about that these are the observation that is given to you. You forget about what is the mean value while generating this data. What is the mean value by generating this data? You have this information given to you. You want to make comparison. You want to make a statement whether the mean of this group is equivalent to the mean of this group or not. This is the main requirement, right? So we will use the same function t.test. Now, in place of writing one variable and in the place of a second variable, in which here it is written as the mean that we want to assign to the one sample case. Now we are keeping these two variables directly. That means whatever the values that is stored in the sea level spending and whatever the values stored in the New York spending, we kept them together. And we are also making a statement that although the sigma is not known to us, because if we are saying directly from the data, we can say that sigma is not given to us, but that is equal. That is the assumption that we are trying to make. So when I execute this command, so you can see that it shows that you have done two sample t-tests, in which the one group belongs to sea level spending and second group belongs to New York spending. And if you remember the formula for the testing of two sample t-test, the formula was x1 bar minus x2 bar minus mu1 minus mu2 upon square root upon sp square root of 1 upon n1 plus 1 upon n2 that follow t distribution with degree of freedom n1 plus n2 minus 2. Okay, so that's why the degree of freedom is 98, because n1 consists of 50 observation, n2 consists of 50 observation. When you subtract 2, okay, so 50 plus 50 is 100, minus 2 will be 98. Okay, so now t, after solving that formula, we got the t value as minus 2.6592. Now, what is the beauty of the software? You do not have to compare this value of t from the table. You just have to see the p value. Okay, so what is the criteria to make a statement from the p value? If the p value is coming to be less than alpha, that means we reject the null hypothesis. If the p value is greater than alpha, we do not reject the null hypothesis. All of you agree with me?
Yes, sir.
Okay, so now you can see that obviously it can be observed that the mean of the first sample, that is sea level, was 250. The mean of the second sample was 300 because we have generated the data using this means. In the first group, we have generated data using a mean of 250. In the second sample, we have generated data using 300. So automatically they are different. But we want to prove this thing from our test statistics. So we see that the p value is coming to be less than 0.05. So we can state that the null hypothesis got rejected. That means the mean of the sea level, that means mean expenditure of the sea level, is not equal to the mean level of the New York spending. Okay, and you can also conclude to the same statement from this confidence interval. Why so? Because if we have a confidence interval in which 0 values lies, listen to me again. So if we have the confidence interval in which zero values lies in the confidence interval, then your null hypothesis is true. We do not reject the null hypothesis. But here you can see that zero value doesn't lie in this confidence interval. So it automatically rejects the null hypothesis. Idea is clear to all of you? Okay.
Yes, sir. It's clear.
Okay. Okay. So now come to the testing of pre and post. Do you remember what is pre and post? What is pair sample data? In the pair sample data, we have same number of observations. We have same number of observations, but we want to test that whether there is a significant difference in their mean value at two different time periods or not. Okay, I am going to repeat with one example again. So let us suppose there is a student who has enrolled in the course of you can say financial mathematics or statistics, right? Okay, and the person got admission in the year of 2024, right? And the course duration is 1 year. And so if someone and the person wants to appear for any competitive examination, so person know some of the questions prior before joining the course, but the person is not able to answer those questions that come from the statistics subject. Okay, so person wants to enroll them himself for the course, and after completion of the course, now person is capable to solve those questions, right? So we want to test that whether the course is helpful for the person to gain knowledge about statistics subject or not. So here there is, because we already have considered that so one person can be generalized to 100 persons. That means we can take a group of 100 persons and we implement the same theory. That means same criteria for the 100%. We observe them before joining the course and we observe their knowledge level after completion of the course. So here we want to make a statement that joining the statistics course, whether that is beneficial or not. So our null hypothesis is that the joining of statistics course is not beneficial. And alternative is that the joining of the course is beneficial, right? So now to implement such type of cases, so let us suppose I want to generate 1000 observations. Okay, that has mean value of 145 and standard deviation as 9. Now you can think about that mean represents, you can say the IQ level after completion of the course, and 138 represents the IQ level, or you can say marks of the students of before joining the course. Okay, so now when I execute this command, so what I am doing here is I am generating 1000 values in which the mean value is 145. That consists of standard deviation as 9. So when I execute this, so I got 1000 values, right? Similarly, I got 1000 values when I execute the second variable post treat. Okay, so now I want to test that whether any, you can say technique or any medicine or any drug or any criteria or any knowledge the person got from the course is beneficial or not, is significant, that has significant impact in the performance of the student or in the health of the patient or not. So for that, we will use the function t.test. Listen to me again, t.test, we will use the same function. We will put these two vectors as it is that we have considered in the case of these two cities. But now the only difference comes here is that we have to write down as paired. That paired is equal to true. So when you write down paired is equal to true, that means we are doing the testing for the paired sample data. Okay. So when I execute this command, so it shows that we are doing pair t-test and we derive the test statistics in that we already have discussed. So now we know that in a single sample, we have 1000 observations and we already have discussed in the paired sample t-test, the degree of freedom is n-1. Okay. So in the same manner, it is coming as triple line. And now you can see that p-value is coming to be less than 2.2. e power minus 16. So can anybody tell me the meaning of e power minus 16? Does anyone has any idea? So e power minus 16 means 10 power minus 16. Okay. So it means we are multiplying 2.2 into 10 power minus 16. So it means we have 0.15 times 0. Then we got the next number as 2. So it is very, very, very small value that is close to 0. So it means p value is less than 0.05. So automatically we reject the null hypothesis. It means that there is a significant difference in the values for pre and post cases. Okay. And one can also test the same using from the confidence interval, because there is no zero value slice in the confidence interval. And based upon that, you can say that there's a significant difference in the performance both in the pre and post case. Okay, is it clear?
Yes, sir.
Okay.
Absolutely clear.
Okay, fine. So there are some things related to the R programming I want to tell you, because due to shortage of time, I first thought that I should not discuss, but I want to discuss now. We have time, 10 minutes with me. Then we will open for the we have open discussion regarding the things. Okay, okay, let me tell you. Okay, so now how many of you are aware about term histogram? And can anybody explain me what is the role of histogram?
I think it's plots the scatter diagram. The scatter.
Okay, so
That is
basically, okay, let me tell you. So when
mainly used in regression, I think.
okay, let me explain to you, because I got some, that you have some idea, but not the complete. Okay, so let me show you what is histogram. So when I use the function hist, so then when I execute this function, so I think all of you can see this graph.
Yes, sir.
Okay. So now what is going on here? So what is histogram? Basically, histogram is constructed for the continuous variable values. Okay. So what is the meaning of this thing? So we start from 0. Okay. We construct some intervals here. That means 0 starts from here. Maybe we have some value 110, 120 here, 125 here, 130, 35, and so on. So it can be 105, 115 also. So basically, these bars show the frequencies. Okay. So what is the meaning of this frequency? That we can say that there are 50 values, approximately 48 values lie in the interval of 125 to 130. Okay. So we can say that there are approximately 100 values lie in the interval of 130 to 25. Okay. So why we construct the histogram? Let me tell you. Okay. So as already discussed last time, that whatever test we have discussed today, that means either today or yesterday, that we have used one sample t-test, we have used one sample jet test, we have used one sample proportion test, two sample test. So these tests can only be used when our data set satisfy the assumption of normality. Okay, what is the assumption of normality? That our data set should follow normal distribution. Is it fine with all? And what is a normal distribution? A bell-shaped curve distribution is called a normal distribution. So now you can see that when I draw a line by joining the midpoint of these bars, so it seems to be like a bell-shaped curve or not?
Yes, sir.
Okay. So why so? Because we already have generated this data from the normal distribution. So when we plot this observation, it comes from, it seems like a bell-shaped curve. Okay. So when this assumption of normality is satisfied, then only we can use the test that we have discussed today. Okay. And how to test the assumption of normality? So let me tell you some brief about that. Give me 1 minute. Okay. So let us suppose I have one data with me because I already created the syntax for you. So to you can say to save the time. Okay. So I have one data that is called iris. That is inbuilt data set that is stored in the you can say memory of R. Okay. I call this data iris. Then I also want to see other means variable that is stored in this data frame is. So first, let me show you what we have in this iris. So this iris data set will consist that is inbuilt data in the memory of R. So I'm not doing anything. I'm just writing iris. So you can see that it will consist of these variables sepal dot length, sepal dot width, petal dot length, petal dot width, and species. Okay. So now, if I want to cross check that while plotting that whether my this sepal dot length, whether it is normal or not. Listen to me again. I want to cross check whether my variable sepal dot length that follow normal distribution or not. So just simple example I want to give to you. So what we got here. So when I see from this plot, so there are few spikes here. It means there are spikes. That means these spikes show the frequencies. Agree with me? And when I see this plot, I can't construct a single curve that seems to be like a bell-shaped curve. I think the idea, whatever I want to convey to you, that is clear to you or not. Otherwise, I have to take one more example for your understanding. So let me first plot. First, see what I'm trying to say. What I'm trying to say, so from this histogram, when we construct this histogram bars, so I can't put a single curve that seems to be like a bell-shaped curve. Okay, either I joined this bar midpoints, so you can see that a bell-shaped curve cannot cover the bars. So either if I construct my curve in this manner, starting from here till here, this bar will be outside, this bar will be outside. So it seems like our data is not coming from the normal distribution. So this is the one criteria. One can test the normality. The another criteria is called ks.test. And what is ks.test? Let me first tell you from the theory. That is called Kruskal-Wallis test. Sorry, Kolmogorov-Smirnov test. So what it do? So you consider one vector in which you store the values. In the second vector, you assume that your data set is coming from a normal distribution, and you put this criteria that we are testing on the both sided. And if the p-value of the test statistics is coming to be less than 0.05, then we reject the null hypothesis that our data set is coming from the normal distribution. If it is coming to be greater than 0.05, we can say that our data set is coming from normal distribution. This is one example that I'm going to do in front of you. Okay, so what we are doing here is we are generating 50 observations from the normal distribution, and we are storing these values in the x variable. In the second case, we are generating 30 observations from the uniform distribution and storing these values in the y. So when I execute this both command, so I got 50 values stored in the variable x. I got 30 values stored in the variable y. Right? And I want to make a comparison whether these two data set, because I got the data, now forget about from where I generated them. I want to check that these two observations, whether they are coming from the same distribution or different distribution. So when I execute this command ks.test, okay, by putting the variable both together, x comma y, when I executed this, So you got the p-value is less than 0.05. So it means that the data set that we have taken for x, the data set that we taken in the vector y or variable y, they are entirely different. So in the same manner, you can say that, so let us suppose I have, in place of R uniform, I generated 30 observations and with the mean of 1 and standard deviation as 1. Okay. So by default, so if I'm not writing here something, it means that the data set is coming from normal distribution having mean 0 and standard deviation as 1. Okay. And here I'm putting a specific value of mean. So now what I'm going to do is I'm going to check that both data set is coming from the normal distribution, but here the mean is 1. In the previous case, the mean is 0. Okay. When I execute this test, so you can see that still it's going to reject the null hypothesis. The null hypothesis says that both these distributions are equivalent. That means both the data set is coming from the same distribution. This is my null hypothesis. And alternative one is these two data set are coming from the different distribution or the same distribution with different parameters. Okay, and from the KS test, we got the answer that our null hypothesis got rejected. So it automatically says that the data set is coming either from the different distribution or the same distribution with different parameters. Okay, so this is the criteria to test the normality. So I think we should open the session for discussion. And do not worry, I will share the code with you that I have discussed with you today. Okay, so you can practice them, and there is no any specific file is required for the execution of this code. So just have to know how to execute it. For the execution purpose, either you can select it or click on run. This is the one option, or either you can keep the cursor either at the starting of the code or at the end of the code, then use a shortcut as Control plus Enter. In the both way, you can execute the specific line. So, Dr. Meher, are you there?
Yes, sir, I am here.
Okay. So I think we should ask questions from the audience.
Yeah, dear participant, the session is open for discussion. If you have any kind of question, you can unmute your mic and put your query.
And let me know whether you are able to understand our session or not, because
Yeah,
we have planned at the last stage to provide you the codes in R. Because otherwise, if you want complete knowledge of R, then it will take more sessions. That means because R is very vast language. Okay, so I just trying to give you a brief introduction about R in this short time period. So let me know whether you are able to understand the codes that we have discussed today, how to execute it, what is the function, how to do the testing for one sample, two sample.
Yes, sir. We have understood very nicely. I mean, it was nicely explained and it was absolutely clear.
Okay, thank you.
What I would suggest that actually, if we can give more, statistical analysis using R, that will be more beneficial, because the methods are we actually more or less know, but the implementation of R is actually from my end. Actually, I have not much done in R actually.
Okay,
So
sir.
that part, so today's session was very, very useful for me, because I learned a lot of codes and syntax from your side.
Okay,
So
thank
it was
you.
fantastic.
So actually, sir, we have to also cater the whole audience, and based upon
Yes,
that,
yes.
we first provide them the theory. Because
Yes,
if
yes,
we
yes.
just directly start with the R programming, then if they do not know the theory, then it is very, you can say, injustice for them.
Right, sir. Right,
So,
sir. Absolutely. I agree.
so basically, what we can do is we can plan a complete session. That means how to do such thing in R. Okay,
Yes, yes.
I request Dr. Meherchand to arrange a session with an expert. And if you will, if we have such a workshop in future, that we will do these things in R programming only, or we can also use other
Yes.
softwares like Excel, SPSS, and JAS, whatever the tools we have. Because this workshop, we first want to help the audience to understand the theoretical part, because that theoretical part is missing while they conduct any study. So we try our best to give some theory. Based upon that, they can develop the things in their mind about the
Yes.
statistics. Then only then you can use this theory in programming in better manner.
Right, absolutely, sir.
Okay. Any other audience?
Sir, I think, sir, can you just also give, I mean, today is not possible, in future actually, regarding the chi-square test actually, because
Yeah.
chi-square test
So-
is very important.
So there are
Chi-square
a lot
test
of things I want to cover. So I also want to cover ANOVA, but due to shortage of time, because if I want that everyone must understand. If I'm going to just hurry up the things, so that will be very injustice for them. So that's why I try to give more examples in my presentation, that you can understand from one
Yes,
side,
yes.
another side.
Examples are very good, sir. I understand each and everything in our.
Okay, thank you.
It's fine, fantastic. I could relate what yesterday's theory with the one that is done today with the practicals. It was fantastic, sir. Everything
thank you.
I could understand.
And any other person can share their experience, whether they are able to, whether we are meeting your expectations or not. That is again a very important thing we want to know.
So I have a question, sir. Is this this non-parametric test, the one that you did in the end, the Kolmogorov-Smirnov test? Is
So
that
yes. That
is
is
that
it's a non-parametric that is basically used for testing for the normality.
yes, sir, sir? Is that more advantageous than the normal test that we use?
No, basically
mean-
there are various tests available in the literature. One is Kolmogorov-Smirnov test, one is Shapiro-Wilk test, other one is
Yes.
Jacob-Abira test, right? So there are various tests available. You can
Yes.
also testing the normality through QQ plot, PP plot. Okay.
Yes, yes.
So basically, I have just considered one test and shows that one can do use this test for the testing of the normality. Okay.
Yes. Okay, sir. Okay. Thank you, sir.
Okay.
Dear audience, if any question, please, you can unmute your mic and put your query.
Or one can share the experience also, whether
And
how much they have
Also,
learned.
please share your experience for these two sessions. This will be beneficial for us as well as for the speaker also to improve the quality and what you need in the coming sessions. This will help us.
Yeah, thank you. I think basically the two sessions have been wonderful. Yesterday and today, especially the practical aspects. These are stuff. I just hope the course will be available so that I'll be able to, have a better understanding of it. So I'll be able to marry the theory and the practical by going through the course and probably improve on what we have. But so far so good. As always, it has been good. A session so far.
Okay, thank you. Thank you for listening. Anyone else? There are some other participants also, like Anjali Soni, Nidhi Patel, Mohammad Abbas.
Nidhi Patel, Alina, please put your query.
So if you have it's okay, you can put your things in chat also. It is not required that you have to come on the mic. You can share experience on chat also. That is also fine with us.
Himashu Agarwal. Sajal.
I think maybe they are either they left or okay.
I think there is no more question from their side.
Okay.
Seema Mandal, are you there?
Yes, sir.
Yeah, please, any question or you can
Share your
share
experience
your
also.
experience.
नो अभी तो आज मेरा सेकंड क्लास था, बीच का क्लास तो मैं अटेंड नहीं कर पाई, तो इसलिए वो
Okay, no.
रिकॉर्डेड देखना पड़ेगा, फिर क्वेश्चन कर पाऊंगी.
Okay, fine. That's also
Fine.
honesty is also very good thing, you can say. Okay. Okay, thank you.
Thank you, sir.
Dear participant, the recordings of each session are available and the link of each we share with you regularly. Also, the queries which you put during the more practice on these related to R programming. In the coming sessions also, most of the sessions are based on using R programming, and basic concept about R programming presented by Dr. Harmanpreet Singh Kapoor will help you in the coming sessions also. If you have any challenge, we always share with you feedback form, so you can put your query, and this will help us to improve the quality and to manage everything according to your desire, which will be beneficial, or we can manage accordingly. So your feedback is also always very important for the event as well as for the organizers and for also the speakers, so that we can jointly improve and we can manage everything according to the requirement, so that in the coming sessions we can organize the coming event in more fruitful manner. And I hope that this will be very helpful for you. We tried to introduce the R programming and in the coming sessions, so that everything will be in a balanced manner. But without the basic concept of statistical method or the models, R programming is nothing. Okay, but if you have the basic concept are very clear, we know and we understand that there are several participants who are a beginner, and some of our non-statistical persons. So they need a basic foundation of the statistical method and how these methods are helpful, how we can apply for their finding for statistical analytic. Okay, so in the beginning, theoretical part is very important. And now in the coming sessions, I hope that everything, theory as well as the practical part will be in the balanced manner, so that this will be very beneficial. And as well as there will be some type of the project will be delivered in the last or in the previous session. Because some of the experts who are working in health science, they will present some project based session will be there. So I think all over will be very beneficial, helpful to all of you. And thank you, dear Professor Harmanpreet Singh Kapoor, for your valuable and knowledgeable session. Lot of efforts are required to manage and to organize this session and to present the content. This is very typical task, theoretical as well as for the using the R programming. So I hope that all these sessions which we conducted during these 4 sessions, all will help you in the coming sessions also. And the content which has been presented during the past 4 sessions, all has been uploaded in the Google Drive link. But today's session and the last we will upload as soon as we have. And you must submit your feedback form and any query which is related to the R programming. So the basic concept, if you have still any problem, don't worry, we will support you by organizing the special session. After the event, if this event is over, don't worry. If you have any challenge in the future, after post the event, you can contact us with the speakers, as well as you can write to us. We will really support you after the event also, so that you can have support related to the computing as well as the statistical method which are required for your domain. So once again, thank you to all to join this session, and tomorrow we will start the session at the same time. Thank you to all, and thank you, dear Professor, for your valuable time
Thank you,
to
sir.
present and your content. Thank you very much. Thank you to all. So now this is time to end the session.